And what we are going to cover in the future in this part, in this week, is this binary search tree, a simplest structure of the tree structure. Binary tree is the tree with degree 2. If we have degree 1 tree, that's linked list. So it's not a tree actually. So at least it should have at least degree 2 so that it can make the simplest tree, binary tree. But it's not a binary tree, it's called binary search tree. It has more conditions to facilitate the search operations. So here, it has a degree 2, but this tree is designed for a fast search of stored data. Fast search. That's the key. It supports search. Quick search. So far, we have studied the definitions and the characteristics of the stored data, how we can structure this. That's what we learned so far. We just know the terminology and the basic structure of these trees. And we are in the rest of this week, we are going to learn how we can structure these trees, right? And this is related to the operations, and that's the thing that we are going to discuss in the implementation part, which will be discussed in the part 2 of this week. How to perform a fast search? How to perform? So it's called binary search tree. So it must have a head of search. It must have the search speed. How it supports the faster search? That's our initial questions, right? Actually, to explain this, we are going to go back to the real start of this lecture. This analogy, the hotel lobby analogy. You want to find a restroom in the hotel lobby that you are really the first time you visit. And how you can find the restroom? We already talked about a lot of this in the offline course. You can just walk around until you hit the restroom and you are going to pee on your pants. Sorry about that, right? That's bad. Or you can see some sign, toilet here, but it's not going to be a big sign, right? It's problem. You can ask around, okay, I want to pee, where is the restroom? And that works all right, but you have to ask, right? It's cumbersome. And what you can do is guessing. It's the smartest move. You are guessing that the restroom is near elevator shaft or the stairwell. Actually, that's the usual place where the architectures put the restrooms, right? So that you don't have to pee on your pants, and you don't have to ask. You can just go the usual suspected place to find the restroom, right? And what happens in the binary search tree. So let's imagine that we are going to store these 4 numbers here, account numbers, 1001, 1002, 1003, and 1004, right? And in the linked list, we are going to store 1001, 1002, 1003, and 1004. Let's imagine I'm finding 1004. Means that we have to do 4 retrievers. And somehow binary search tree can reduce this number of retrievers with a special structures and conditions. Thing is that we are going to make a very simple rule. Here, we are going to call it node, right? In the middle, we are going to call it node value. And this value is called left hand side node, right? In short, LHS. You often see LHS, and that's the left hand side acronym of the LHS, right hand. And it has the RHS, right hand side node. And our rule is very simple. In this tree structure, somehow someone made this, but that someone followed this rule. Node value has bigger value than the left-hand side node value, and it has a smaller value compared to the right-hand side node value, like this. This simple rule. This is big, this is middle, this is small, right? Left-hand side, small, middle, medium, right-hand side, big. A very simple rule, right? And you hit 1003 here. Somehow you hit 1003 here. And then you want to find out where the 1004 is. And then where the 1004 is. Where the 1004 is. Actually, 1004 is at the right-hand side. Because 1004 is bigger than 1003. There is no reason to search through left-hand side. If this person who made up this binary search tree structure followed the rule correctly, in that case 1004 is bigger than 1003. It's not going to be in left-hand side. It's always going to be in the right-hand side. So that you can just traverse to the get next to the right-hand side, and you retrieve 1004, and you can find this value with a single retrieval. So that's wonderful, right? It supports the faster search. Of course, you might be puzzled how this works, and you have to understand how it operates. You have to know understand the operations, which we are going to cover in the part 2. In this first part, you don't have any programming requirements, right? I didn't show any programs and code lines here, so then you don't have to type. But in the second part, we have a bunch of code lines, so that you will have fun in typing this, right? I'm going to see you in the next part, right? Thank you for listening.